In this video I'm gonna show you how I made Nema 17 motor gearbox for my CNC plasma table. This gearbox was supposed to have 1:7 reduction ratio, but it turned out to have 1 to around 24 reduction ratio. Here are the parts that I'm gonna be using. Most of them are 3D printed. I'm gonna be installing the gears in reverse order than they were in the CAD, because the drive gear for the motor can't go as low as it did in the CAD, so I'm gonna mount it on top, and that means that the drive gear of the output is gonna end up on the bottom. Now it's time to push in the bearings. This laser cut piece of stainless steel was the best tool that I had, but I wouldn't recommend doing it this way because I'm also tapping on the inner race of the bearing, which may damage it. There are no retainers for the bearings. I usually would put those in there, but I'm trying to keep this gearbox as small and simple as possible. And the pressure required to push the bearings in is enough to keep them in place, and it's a plastic gearbox. There's not gonna be any forces trying to push the bearings out, so they are not coming out even without any retaining clips. Okay, so this is how it's gonna spin inside the case. As you can see, the top bearing is spinning really slowly, while the bottom one is spinning fast. So the bottom one is gonna be driven by the motor. So one of the gears was kind of wobbly, and here I'm trying to obsessively fix it for like 5 minutes. In the end I found out that it doesn't really matter that the gear is wobbling, because there's enough play in between the bearing and the shaft that the gear doesn't really push with any force while wobbling, so it doesn't matter. Here I'm mounting the bearing seats in the case. I decided to do them separately because that let me save some space. The bearing seats can now stick out of the bottom, which wouldn't be possible with 3D printing on like flat bed. So yeah, that's plus 2 millimeters on each side. So the drive gear is installed and it's not spinning that well. It's actually really hard to spin it. I'm adding a little bit of heat to the plastic screws so that they form a better thread. But if I overheat the screws, they start pulling a little bit of plastic out of the holes, which later have to be corrected with some knife. I tried to spin it in reverse, but I just broke something, and now I've got this play that's gonna have to be fixed later, which means I'm gonna have to disassemble everything. I tried to test it with my printer. I connected it to the extruder wires to see if it spins, but it just skips steps. So yeah, it doesn't work. I tried to add some special plastic grease to the gears to make them spin easier. Maybe that would fix it. Here I found out that there isn't enough vertical space in the housing, so if I push it down, the gears just stop spinning. So I printed a new one that was too large, so I printed a new one, and now in this new case I'm able to drive the gears while the case is closed, but in this situation there still isn't any gear attached to the motor shaft, so we're not driving the motor, we're just driving the freewheeling gears. Okay, now that the gears are spinning semi-freely and I've installed the drive gear for the motor, we're able to test it again on the 3D printer. Let's see if it works. No, it still doesn't, and even if I try to help it, it just skips steps, it doesn't spin. Luckily I found the issue. The set screw on the small gear pushed out some plastic which interfered with the teeth and the motor couldn't push through it. So I tried to remove this plastic with a knife, but somehow it didn't help. So I printed a new gear with a additional hole on the entrance of the set screw with a larger diameter, and that fixed the problem. Success! It's finally working. So now, after this whole lot of messing around, I can confidently say that 3D printing and gears are two words that should never go together.